All right then. So good afternoon, everyone. It is a pleasure to be here today on another ABAV webinar. That's the Brazilian Association for National Assessment. We're carrying out a number of webinars this semester, really, because of the pandemic. We weren't able to have a conference. And today we'll have a session with Professor Ben Domingue. Professor Ben Domingue is a specialist in assessment from the University of Stanford. Professor Heliton Tavares from our consulting board. Professor Ruben Klein, also from the consulting board. And Ricardo Primi, the academic director of ABAVE. So I'd like to thank you very much for joining the session, and I'd like to thank Priscila, Leandro, and Sylvia as well, who were pivotal in organizing this webinar and organizing the interpretation and everything else. So a special thanks to Leandro, Sylvia, and Priscilla. And to Taisi, of course, I can't forget her. The four of them worked very hard for this webinar to be taking place now. So I'd like to thank you all, and I'll turn the floor over to Professor Premi now for him to introduce Professor Ben Domingue, who will then be speaking to us. Professor Premi is one of the coordinators of this webinar, and he will be introducing all of the speakers tonight. So thank you very much, and enjoy the debate and the webinar. Today we're going to be addressing an extremely important subject, which is vertical equating, key concerns and connections to other issues in educational measurement. This is really a subject for the big minds and specialists here in Brazil and in the world. Thank you very much. Ricardo, over to you. Good afternoon, everyone. Thank you, Marilena. So let's get started then. Thank you very much for joining. I'd like to thank Abave and everyone, and thank you, Ben, for joining us for this session, and Ruben and Heliton as well. It is a pleasure to be moderating this presentation. Ben Dominguez is a professor at the Graduate School of Education at Stanford University. He's a specialist in education assessment. He has many he does a lot in many areas, but I'm not going to speak too much because he's only going to be introducing himself as well. And he's going to be addressing you for about 40 minutes. And in this presentation, you should feel free to use the Q&A button at the bottom, but also the interpretation button to be able to listen to the translation if you prefer to listen to Portuguese instead of English. And again, if you have any questions, do use the Q&A button on Zoom so that we can cover them at the end. Leandro and myself will be keeping an eye on it, and we'll address the questions at the end of the session. All right. So we'll also have, after the presentation, a few comments from Professor Ruben Klein. He's a statistician and a mathematician. I think you all know him very well, and also Professor Heliton Tavares, who is also a statistician and from the Federal University of the state of Pará. As you know, they are very much engaged in assessment in Brazil, and they're possibly two of the main minds focusing on the system and working for SAEB as well, the basic education assessment system. So the idea is that we should address some technical issues related to assessments, especially looking at common scales that can be interpreted through the grades so that we can do aliasing and understand their development and student development. So Ben, I'm going to turn the floor over to you now. So again, we have 40 minutes for your presentation and then 10 more minutes for Professor Ruben Klein and Heliton Tavares to comment on your presentation, and then we'll open up for questions and answers. All right, so Professor, please.
So you have the floor now. Hello, everybody. Let me share my screen here. Okay, so my name is Ben Doming. I'm going to be talking today about vertical equating. I'm going to discuss some key concerns as it relates to vertical equating, and then I'm also going to try to connect that to a few other issues in educational measurement. Since I don't know you all, I thought it might be worthwhile to give a little bit of background as far as myself. I'm an assistant professor at the Stanford Graduate School of Education. I do a lot of research in kind of classic psychometrics. For example, lately I've been doing a lot of stuff with response time. But over the years, I've also done a lot of consulting work with various educational agencies. These projects are related to either psychological measurement or oftentimes questions related to the use of standardized test scores and accountability systems. And I wanted to flag in particular that I worked with ICFAS in Colombia for several years on a project. So that was my kind of initial experience working in Latin America. And I'm delighted to be talking with another South American group today. I had such an invigorating experience in Colombia. I was very happy to come and speak to you all from Brazil. So vertical scaling is a big topic, and I wanted to kind of bound the conversation that I was hoping to have about it today. So I want to first say a little bit about what we mean by this. I then want to talk about how we're going to do it. And then finally, I want to talk about some of the key difficulties and how we attempt to get around them. It'll probably become very clear that I don't know that much at this point about Brazilian assessments, but I wanted to at least know what I do know at this point. And I spent a little bit of time learning about the two assessments shown here. The ENEM, as I understand it, is a measure that is meant to kind of tell primarily probably tertiary institutions about student performance at the end of high school and whether or not they're ready for higher education. I think it's probably similar to the SAT in the US or the Saber Once in Colombia, as I understand it. The other test that I was trying to learn some about is the SAEB, I think is how you say it. My understanding is that this is a test designed primarily for group level inferences at various points in primary school. It revolves around a balanced incomplete booklet design. So in that case, it's very similar to something like the NAEP in the US or the PISA. So I hope these are kind of generally right, but to the extent that they're not, I look forward to learning more. And I at least wanted to note the things that were structuring some of my thinking as I put this talk together. Okay, so I want to start with a little bit of terminology. In particular, three words get used to describe relatively comparable things, and I wanted to make some distinctions between them. So scaling, linking, and equating all get used to describe a similar process. In particular, all three describe the process of mapping one score scale onto another, right? So I have a little picture here. So these three words all refer to the process of finding some map that takes us from a score on form A to a score on form B, right? So this black line here is the equating map or the scaling map or the linking map. And I want to note that this is not regression, right? Regression has a different property wherein what I want from an equating is X sends me to Y and then the equating sends me from Y back to X. And regression doesn't have that property. Regression does something a little bit different. It's not symmetric in that way. And so regression is not something we use for equating. There is a subtle distinction that has been used over the years with respect to these terms. So equating has traditionally been used to describe scenarios wherein forms A and B are meant to be exchangeable. They're meant to be kind of the same, right? So if you have a very large item pool and you just split it at random into two test forms, we would then talk about equating those two test forms. On the other hand, scaling or linking are more generic terms, and they're often used to describe scenarios wherein the forms are not directly comparable. So maybe you have a form A that's designed for third graders, form B is designed for fourth graders. We want to scale or link those two forms, but we wouldn't say we want to equate them since there's a bit of a difference between those two groups of test takers. I think it helps to start the conversation about equating with just a simple thought experiment that hopefully points to the fundamental problem that we have. So suppose we have a large group of students. Well, actually, suppose we have two large groups of students and 100 math items. So group one takes a subset of 50 math items and they get 35 out of the 50 correct on average. right? So they get 70% of the items right. Group 2 takes the other 50 math items and they get 40 of the 50 right. They get 80% correct on average. So the question here is, what can we say about differences in performance? And the answer is nothing, right? If that's all the information you're giving, you can't really make any sense of it. In particular, we don't know whether group 1 should be thought of as doing worse, right? Since they got fewer items correct on average, or if the first set of 50 items should be considered harder, right? That's another possibility. And so if we're willing to make some assumptions, we can then hopefully make some assertions, but without more information, there's just nothing we can do with this. So we're gonna have to enrich what we're working with in this thought experiment. So let's suppose as follows. So what if we knew that the two groups of students were formed by randomly splitting a large group of students? Well, in that case, assuming we have big enough samples, we would probably be okay expecting these two groups to be of average, to have the same average ability, right? If the two groups were formed at random from some large group, we're probably content to say that ability is about the same in those two groups. And if we assume that in this case, in our thought experiment, we would conclude that the items taken by group 1 are harder than the items taken by group 2. We've assumed that the abilities across the two groups are the same, so the only difference in performance is due to differences in the items, right? So we assume that the items observed by group 1 were just harder than those observed by group 2 students. So the assumption there leads us to believe that the difference in observed performance is due to differences in item difficulty. Now, what if we instead made a different assumption? What if we instead assumed the items were of equal difficulty, right? So maybe we had created the items by randomly splitting 100 items into two groups. Well, in that case, we would assume that would end up implying that group 1 is of lower average ability, right? Group 1 did worse on average. If the items are the same and we have reasonably large sample sizes, then we would be comfortable assuming that that's because group 1 is of lower average ability. Maybe they're younger students, for example. So right here, the assumption leads us to believe that the difference in observed performance is due to differences in student ability across the two groups. And I want to note that, we have to kind of pick one of those two here, right? If we tried to assume both things, we would just have an incoherent muddle. There's no way of having both of these things be true. If we have large samples, the data that I presented are just not consistent with the students being of equal ability and the items being of equal difficulty. Only one of those things can be true. And I'm going to come back to this a little bit later when I talk more about some of the scaling practices that I think are used in Brazil. And I think that'll be somewhat related to this issue. So, okay. In general, what I talked about in the previous slides is fine if we want to do certain kinds of equating, right? Like, so if we want to establish two forms to be used for the same grade students, then I can do kind of randomly equivalent group designs. Oftentimes, we need something more sophisticated because we have kind of harder problems to solve. So now let's talk about some of the equating designs we use in applied settings. So the assumptions that I mentioned before are useful when scaling needs to happen for groups of approximately similar ability, right? When I have a bunch of kids that are, basically from the same grade and I can randomly split them into two groups, I can use the stuff on the previous slide to equate forms. That's often known as horizontal equating. Vertical scaling, right, what we're here to talk about today, is what we do when the groups are known to be different. And in this case, we're just not going to be able to assume that the two groups are of equal ability. I mean, the whole point is that we have two different groups that we want to have a scale that runs across each group, and we're just not going to be able to assume that they're of the same ability. So what do? Well, we tend to rely upon assumptions about the items. We're not going to be able to assume that the students are equivalent. It would also probably be inappropriate to give kids in different grades all the same items, right? We're not going to want to give them the exact same scale because there are grade-specific bits of content that we probably want to emphasize in the different scales, so we need to account for that. And this all leads to what is known as the NEAT design, the nearly equivalent anchor test design. And basically what this does is it solves the vertical equating problem by embedding common or anchor items across the forms seen by students in adjacent grades. And so just a bit of terminology. So The anchor items are also referred to as common items. People use both of those terms. Maybe in Portuguese, there's only one word that gets used, and so this isn't a problem, but in English, you see both words. Okay, so what does this actually look like? So here's a little schematic for a potential set of forms that are going to be equated via the neat design. So we have students from grade 4 and grade 5. The students in each grade take the items shown in red, right? So I have a large item pool of 25 items. The students in grade 4, so they see this block of items, and then they see this block of items, and then they see this block of items. Students in grade 5 see this block and this block, and the magic here is that we have some items that are common to the two forms, right? And that's going to be the basis for our equating design. So what we're going to do is we're going to use information regarding item functioning to put students from grades 4 and 5 on a common scale. You can recall earlier that I in the thought experiment, suggested, well, what if the items were of comparable difficulty? We're basically going to do something more sophisticated, but using that same notion of using item information here. Specifically, what are we going to use regarding item functioning? Well, that's really going to be facts related to item response theory that I'll talk more about in a few minutes. And where do we get this knowledge about item functioning? This is an interesting question. It can be obtained in a variety of ways. It can be obtained from historical data collected on item functioning. It can be obtained in real time. I'm going to talk more about this in a bit. As I understand it, I'm inclined to think that in the Brazilian context, it's the first case where you collect or you use inferences from historical data, but we can come back to that. So let me pause here. I am not entirely sure if you guys want to hold all questions, but if there are any clarifying questions, especially, I would be happy to take those now so that people are able to follow.
And no, I think we are okay. And
okay.
So far, so good now. Okay, thank you.
Excellent. Okay. So now I want to talk very briefly about item response theory. Item response theory is the thing that undergirds this enterprise. It is the information about item functioning that we're going to utilize. And so we really need to know a little bit about it. So item response theory, or IRT, tells us about the probability of a response in a given score category. So in this case, I'm largely going to think about correct or incorrect responses as a function of the person's unobserved ability. So at right in this little figure here, what we have is on the y-axis, the probability of a correct response as a function of student ability on the x-axis, right? That's these numbers here on the x-axis. And the way item response theory works is it parameterizes things in terms of item stuff and student stuff. So on the item side, we have the A, B, and C parameters that are in this equation, and that are also reflected in this figure. So B tells us where the item is in terms of its location over the x-axis, right? This is the parameter we refer to as item difficulty. A tells us about the steepness of the line here. This is the parameter known as item discrimination. C tells us about the lower asymptote of this curve, and this tells us something about guessing potentially. The notion is that no matter how low ability a student is, if they can guess, there's never a 0% chance of them getting the item wrong. There's some lower floor on the probability of getting the item wrong because they can guess. And then we think about personability, right? So personability is theta, it's here in the equation. It's also the set of running variables here on the x-axis. So basically what you're seeing with this curve is that as students get more able, as we go up the x-axis, we have corresponding increases in the probability of them responding to the item correctly, right? So what IRT tells us in this particular case is about the specific way in which a student, with a specific probability that a student at a certain ability has with respect to answering the item correctly, right? So item response theory kind of clues us into these values. It says for a student of this ability, responding to this item, they have this probability of getting the item correct, right? This is what we get out of IRT. Now I've parameterized things here in terms of 3 item parameters, but other choices are possible. Item response models for polytomously coded data, for example, if students can get multiple points, are also available. So there's lots of additional stuff that one can do here, but this is the basic model that we're going to use. And I'll use this simple example in a few minutes to motivate the mechanics behind vertical scaling. Okay, so one thing you might wonder is where do all those values on the previous slide come from? And that turns out to be a hard question because the basic problem is that if you think about it, we don't observe anything here on the right-hand side of the equation, right? We don't observe a priori the A, B, or C, or the theta. We have to make estimates of all those parameters. If you think about something like logistic regression, which is somewhat similar in some ways, the big difference would be that there you observe some independent variable x, right? So it would be as though we observed x here, or I'm sorry, it would be as though we observed theta here. We don't observe theta. We have to make estimates about it. And we have some estimation challenges given that everything on this side is unobserved. So how do we deal with that? Well, the logic basically works as follows. If we knew the person parameters, right, if we knew the thetas, we'd be able to estimate the item parameters, A, B, and C, via maximum likelihood. We don't know the person parameters, and so one early solution was basically to integrate out the person parameters, the abilities, in what is known as marginal maximum likelihood, or MML. And to do that, all we had to do was make some assumption about the distribution of abilities, right? We might assume that the abilities have a normal distribution, for example. And this was helpful in that it gave us estimates about the item parameters, but it did require an assumption, right? It required us to assume something about the distribution of abilities. You can imagine there being some sensitivity to that assumption, right? So that's something to worry about. These days, we don't do MML exactly. We do typically something known as expectation maximization, and this is basically a refinement of the MML approach. I don't want to talk too much about it, but if you've heard of the ENEM algorithm, it's not entirely unrelated to the basic idea of MML. Okay, so that gets us to item parameters, right? I basically marginalized out the ability parameters. Well, what about the abilities? Well, this is actually much easier. If we know the item parameters, then we can just use maximum likelihood to estimate the abilities, right? If I know A, B, and C, I can just use maximum likelihood to estimate the thetas once I have this, string of a person's item responses, right? So collectively, this kind of two-step approach where I first estimate the item parameters, and then I use those parameter estimates to get the person parameters, this is how we calibrate IRT items, IRT models. Okay. So how are we going to use IRT for equating? So I'm still showing you the same item response function, and I'm now going to talk a little bit in kind of rough detail about how we do this. So we're going to have to make another assumption. We're going to have to assume that the items function equivalently across groups. I'll say more about this in a bit. And if we're willing to make that assumption, we can use those to create a common scale. So how does this work? And I want to just caveat that the illustrations that I'm going to show you are meant to offer some intuition about what's going on. They are not a technical blueprint to get you to an actual IRT equating algorithm. So kind of be aware of that. This is more for intuition building rather than technically precise purposes. So let's say that we give a bunch of fourth graders, right? These are the folks in blue, an item, and half of the students on average get it right? So half the students get it right. And so we think that on average, their abilities are about here because I've assumed I know something about how the item functions, right? I know that if the average student has a 50% chance of getting the item right, that corresponds to this ability of 0. Now, we then give the item to fifth graders, right? And the fifth graders of that group, 73% get it right? That's up here, right? This is now the red line. And so we have that map, right? This takes us to a slightly higher point over here. And basically what we're going to do is use this difference in abilities and average abilities between these two groups as the basis for placing the fourth graders and the fifth graders onto the same scale, right? So it's this kind of thing that we use to put everybody on the same scale. Once I understand item functioning, any observed differences in the probabilities of responses are assumed to be due to group differences on the ability scale. So this is the idea that we use when we do IRT-based vertical scaling. Now, as I noted, it's really not quite this simple. And I don't think that some of the technical details are especially illuminating. I think some of the conceptual issues do, however, merit further attention because they are, I think, important to understand since they have real implications for what we do with the scales. So now I want to talk through several of these conceptual issues. So first, if you noted, one thing that I had to assume, I even kind of noted this, we have to be willing to assume that the items function equivalently across groups. This is a big assumption. So why? Well, as kind of an aside that I'm going to come back to in a moment, this is related to the broader problem of measurement invariance. There are a lot of reasons that items might function differently across groups. What we're concerned about here is not differences due to kind of group demographics, but differences due to group age. And so you can imagine a problem as follows. So suppose in grade 4, a given math problem is the focal point of the curriculum, right? So maybe students in grade 4 spend all year learning about adding fractions. If in grade 5, that problem becomes less central to the focus of the curriculum, or the content of the problem is otherwise differentially emphasized, this might lead to some concern about the assumption that the problem functions equivalently across the two groups, right? It might just be that since you focused on the problem all year for grade 4 students, they're more facile with that particular kind of problem and more likely to get it right than would a student of comparable ability in grade 5 who has not spent all year focusing on that kind of problem. And this problem might even be worse if the fractions weren't really emphasized until grade 5, but you're still using a problem involving fraction as the basis for your equating, right? Now, if you have large numbers of anchor items, you can kind of feel a little bit better about this. But anchor items just have to be very carefully chosen since they are at the heart of the mapping between scales. If your anchor items are chosen such that they cannot be assumed to function equivalently, at least on average, you have real problems. And as I noted, I'm talking specifically about the problem of measurement invariance in the context of vertical scaling, but this is just a very big problem in general. So anchor items and vertical scaling might function differently. That causes problems for vertical scales. In general, items might function differently for a whole variety of reasons, as a function of student sex or gender, as a function of student race or ethnicity, as a function of student language background. And these differences in functioning can lead to inaccurate inferences about abilities in different groups. In most high stakes assessments, this is typically addressed via application of differential item functioning or diff analyses. And they're one means of attempting to resolve this problem, but there are other questions you can ask. So you can ask, for example, about the dimensionality or the factor structure of some measure across different groups. But what I really just want to emphasize is that this is a very important problem and that questions of measurement invariance really need to be resolved if we want to make accurate inferences about students from different groups, or if we want to make accurate inferences about aggregates of students. So, maybe students from different states, given especially that students from different aggregates, so students from different states, will likely have very different compositions in terms of the kinds of demographics we worry might lead to variation in function across items. So I want to briefly talk about separate or concurrent calibration. This is a little bit technical, and so I've kind of gone back and forth on whether to include it. I ultimately decided to include it given that some of the most important kind of vocabulary words with respect to vertical scaling are relevant here, and I didn't want you to leave this talk not having understood where those words connected to the content I presented. So the basic question is, how do we make sense of, how do we kind of make sense of item functioning? So I've noted that everything here is possible given that we think we understand item functioning. Well, how do we understand item functioning? Where does that understanding come from? One possibility is that we basically use all data spanning both groups, both of the fourth graders and the fifth graders in my examples, to calibrate item parameters. If we do that, right, if we put all of the data together, that's the kind of concurrent calibration approach. And in that case, things are relatively straightforward. If not, if what we have done instead is to separately calibrate item parameters for one group and then for the other, right? So we have two sets of item parameter estimates. We need to kind of resolve the differences between those parameter estimates. And that is where you use something like the Stocking-Lord approach, right? So Stocking-Lord is an approach for putting two sets of item parameters together onto the same scale so that you can use that one kind of common set of item parameters to go back and forth between score scales. As I understand what happens in the Brazilian context, I believe that there is an item bank that is used for the calibration of student ability scores in different grades. And so this is a little bit the concurrent, well, if you're using kind of historically calibrated item parameters, you don't have to worry as much about this specific separate or concurrent calibration question. You just have to know that you're using historical data that underlies your understanding of student or of item functioning, and you have to kind of trust that. You have to trust that it's good for both of the groups and that it's not changing over time, which is something that I will talk a little bit more about on the next slide. A very obvious thing to worry about is how many common items or anchor items you need to do vertical scaling. The stability of the scaling is clearly going to be sensitive to this. If you just have one item used for vertical scaling, you're going to have a highly unstable scale. It's going to be very contingent upon that one item. Now, what you want in general is more items. That'll make the scale more stable. But the more items that you have in common, the less you're able to tailor the content of a specific form to the needs of the students that you're hoping to target that form to. So there's a tension here. The rule of thumb that I have heard over the years is that you want to use either 20% of the items on the form as common items, or 20 items, whichever is larger. Right? So this is a lot. So if you have a 50 item scale or a 50 item form, you probably are going to need to think about including something like 20% of those items as common items across another form. Right? So it's a large chunk of the items. There are a variety of studies that have talked about how one gets at such numbers. I've listed a few here, but I just want to note that this is a major problem. You really need to think about the composition of and the size of your common item pool when you're doing vertical scaling. As I mentioned on the last slide, especially if you're using item banking, what you need is some assumption that the items have kind of constant functioning over time, right? If you, if you went back 5 years and gave a question about, say, a novel coronavirus, very few people would kind of get that right. Whereas now people have a much better understanding, even just amongst the lay public, about the basics of coronavirus biology, right? That would be a common item whose functioning has really probably changed over time. And so that's what we want to avoid. And so this is the problem of parameter drift. And so my coronavirus problem is a little bit tongue-in-cheek, but the general concern is that if curriculum changes, you might have a problem with parameter drift. If curriculum changes and you're re-emphasizing different parts of content, you might worry that the functioning of items is not really going to be stable over time. Other events in the world can also lead to parameter drift. There's a generic intuition that people have that items tend to get easier over time. I'm not aware of any large-scale empirical documentation of that phenomenon, but I don't think it's wrong to be worried that item parameters are just going to change over time and items might get harder or easier, either of which is a problem. It's also the case that specific events such as test security breaches might lead to items getting easier over time if students learn about the content of certain anchor items. That's a real concern. So those were kind of quasi-technical issues. I now want to talk about some very conceptual issues. And as a kind of precursor to this, I want to acknowledge that I'm borrowing a lot of ideas from my doctoral mentor, Derek Briggs, who's a professor at Colorado, and will actually be the president of the NCME, which is the main US professional organization about educational assessment. And so I'm really kind of channeling a lot of his intellectual energy here when I talk about these issues. So one question is, why do we want a vertical scale? And I want to start with the point that in many cases, it's really not obvious that we need a vertical scale for inferences that we want to make, right? If you want to think about the effectiveness of schools or teachers, if you want to think about normative change of students, those aren't really questions that rely upon having a vertical scale. If what you want to do is measure growth in the sense of how we chart the height and weight of children over time, a vertical scale is likely needed, but to use a kind of colloquial saying from the South, wanting ain't getting. Just because you would like to be able to measure student abilities, in the way we measure child height and weight, that doesn't mean we actually can do it. There's no reason to suppose that scales have the right measurement properties. I'll just flag, this was the kind of focus of my dissertation, thinking about whether or not the scales we construct from item responses are equal interval, for example. And the inferences that we are inclined to make about growth are likely to be highly sensitive to difficult or impossible to test assumptions about our scales, right? So just because we would like to measure ability and growth in that ability, we need to be, I think, very humble about the fact that the scales we have to do so just really may not be sufficient. The second kind of conceptual issue that I want to think about for a minute is, do we really need wide scope vertical scales? And so what I mean by that is vertical scales that span, mathematics in grade 4 to 5, right? So that span a very large amount of content. I think if we're honest, we really probably care more about growth in fairly specific domains that spans grades. And a lot of content doesn't have that kind of character. But for example, the ability to manipulate fractions in an arithmetic sense is a real focal point, at least in the US, of math teaching in grades 3 to 6. And it might well be that we could do a much better job of creating vertical scales for kind of subcomponents of our curriculum that are tightly and vertically aligned in reasonable ways across grades. A lot of work that Derek has done has been in the learning progression space. And the basic notion is just that, you can potentially build assessments that are both summative and formative if you focus on these kinds of narrow spans of content. And if you were willing to do this, you might think about kind of constructing narrow scope vertical scales that might be more informative than the wide scope vertical scales that we have historically constructed. Okay, so I don't have a ton more to say. I'm gonna make a few more points. So one, there's a vast literature on scaling and equating. I've noted a few classics here. The Colin and Brennan book is kind of the scaling Bible. I use this in my class. It's really nice. It doesn't rely on IRT. And it's a good kind of primer. And then this is a very kind of sophisticated book about some of the latest innovations in this space. So these are all things you might want to look at. And finally, I just want to flag that while I still don't know a ton about Brazilian assessment data, I am starting to get my feet wet working with some Brazilian data in the context of work I'm doing with a student, Clint Kanapka. So the basic idea that I'll just kind of pitch briefly so that if anybody's interested in talking about this, they know where to find me, is we're interested in position effects. Basically, there's a lot of evidence amassing that the functioning of items might not only vary as a function of what grade you give the item, but when in the test you give the item. If you give an item earlier, it tends to be the case that it's relatively easier than if you give it later. And so we're working on some methods for developing models that would allow for that kind of behavior. And we're using the ENEM given that it has a booklet structure such that there's effectively random variation in when students see items at different portions of the test. So I think we can now move forward. I think I'm a little bit early, so hopefully that's okay. But I really appreciate the opportunity to talk with you all, and I'm excited to have the Q&A and continue this conversation even after today. Thank you.
Obrigado, Ben.
Thank you, Ben. That was a great presentation. I think we can continue with the comments from Professor Rubens. I think we have a few minutes now. So I'd like to start off thanking Abave for this invitation to debate the subject, and thank Professor Ben very much for his talk. I'll talk a little bit about SAEB, the Basic Education Assessment System, and I've known it since it was introduced in 1995 with Maria Elena. And SAEB is an assessment. It's been expanded right now, but it has been from the beginning an assessment for Portuguese and mathematics from the 5th to the 9th grade in the elementary education, the final years of elementary education. SAEB is for you to be able to compare it to anything, you need to be careful. And we need to have a standardized way to use the test in all of the grades. You can't have one location where the person giving the test will be reading the questions out loud and another location where the student will have to read the questions on his own. So this is an important thing we have to be careful with. And ever since 1997, Saeb has been using an equating method that doesn't use all of the information. It's an IRT, so item response theory with multiple groups, with fixated parameters, and the data that originated these parameters. And if necessary, we'll keep these parameters for the analysis. We've been using this methodology since 1997, as I said. So we equate, and with that, we have a single scale between the grades and the years. And the idea Saeb has is to monitor education, and that has been done since 1995, 1997, using these skills. And from the beginning, Saeb has had common items between the first and 9 years and the ninth grade and the third grade in high school. And we continue to have items between the grade and the following grade, and or 2 grades after. So Saeb is carried out every 2 grades. So we have between the fifth and the seventh grades, for example. And this data is used for equating. I'm not going to go into the ins and outs of it, but we use these parameters as I mentioned more broadly here. So we equated between years and grades, and we do it vertically and horizontally as well. And this is one of the things that we want to identify if we can improve the performance of the system. And as Professor Ben said, all of that depends on anchor items. These anchor items have to be picked appropriately for the same grade and between grades. And we do pre-testing for that. And in pre-testing, we have a good enough sample, we can work with those percentages. But it's important that we pre-calibrate the items so that we can have a notion of what the parameters are going to be so that we can put together a test. And as Professor Ben said, 20% or 20 items between grades or years, that has been used by Saeb ever since 1995.
And also, Professor Ben introduced something that's new to me, which is related to the 20 items, but we have already been doing that in SAB. But when we perform calibration, we have to be careful about some things. We have to look at the functioning of the item. We have to look at the functioning of the common items. We have to understand if they are functioning in the same fashion across grades or across years. We have to check all of that. And we do that. In fact, we do that in SIAB, and that is very important to us, just so that our analysis is accurate. So we check the quality of the items, and even if we use calibrated items only, when you apply, when you administer the test to a new population, you should also check the quality of the adjustments that you made to understand whether or not the parameters that you are using are appropriate to that new population. So we should do that even when we know all parameters. For SAB specifically, we calibrate the new items. So we control for quality, and we also have to understand the DIF, differential item functioning. And what is it? When there is no diff between two groups, you have to understand whether or not the probability to get it right depends on proficiency and not the group. So, in a certain proficiency level, and there is a very large difference between those two groups for that proficiency, if the number of questions that they got right is very different, then you have some insights about the behavior, the functioning of the item. And we have been doing that since the very beginning of SAB. We have been controlling for diff across grades and years as well. And we believe that we have only one dimension to analyze the items. And we have been doing that since the beginning as well. And for example, if there is an item that is not functioning appropriately, psychometrically speaking, or for any other reason, any other instructional reason, we can stop using that item. Or if there is a differential functioning in the item across grades or years, then we can stop using the item for one of the grades, or we can consider that item as two different items. And assuming that the items that we are indeed using, we believe that they are unidimensional. And when an item is functioning poorly, maybe that happens because there is a dimension related problem. But since we drop them, we don't include them in the analysis. That's not a problem for us. And we have been doing the same thing for other assessments as well. And what Ben said is really indeed a fact. The percentage of correct responses may depend on where in the test the item is located. And SAB and ENEM work the same way when it comes to that issue. But let's take SAB for an example. We have a BIB for SAB, and the item can be placed in different parts of the test. The location of the item may vary. And when we calibrate the items, we use students that used all forms. So the position of the item is not fixed, it may vary. And we can calculate the average behavior of the items. And it is indeed a problem. We have to be careful about that, especially for long tests, because students get tired as the test goes on, and the likelihood that they will get an item wrong at the end of the test is higher, or maybe they won't even try to answer that item. So I am favorable to vertical equating, and we have been doing it. And I believe that now other tests are going to be using the SAB scale. For example, in 2013, we used the SAB scale for other assessments. It was possible and we did it. because we built a different scale at that time and we calibrated the items, and the results were very similar. Were very similar to another experiment that we conducted. We took a sample and recalibrated the items for the 12th grade, and we calibrated those items in the SAB scale. And we did that in another assessment in which we assessed 12th grade students, and the results were very good. So I think that can be done as well. And the SAB assessment this year, we actually had a problem with it because it was not administered the same way it is for other grades. The person administering the test read the questions out loud, which is different from what was done for 5th and 9th grades. And that is a problem because the administration was not the same for everybody, and therefore the results are not comparable. And we can use that grade for the SAB scale as well. I believe that the assessment for 11th grade shouldn't be mediated. I believe that if students can read, they will have to read the question and interpret the question, and not having someone read the question aloud for them. And I just wanted to give you an idea of how SAB works and how we analyze SAB results. I actually didn't talk about the interpretation of the scale, which is very important for us. It is absolutely critical. But I believe that I don't have much time left, so I'm going to turn the floor over to Hallington. Thank you very much, Ruben. And Ruben Klein, in 1995, he brought IRT to Brazil when SAB was designed here in Brazil. And he created the entire method for that here in Brazil. So Ruben was the person in charge of that, and he is responsible for this discussion that we are having right now, actually. So now, Ellington, over to you. Well, first of all, thank you very much, Abav, for the invitation, and congratulations, Ben, on your great talk, and Ruben as well. I believe that we should actually keep Ruben in a safe, and many people should have the key to that safe. And I believe that he should be kept that, and we should be careful not to release him, to set him free. We should be very careful about that. And since we still have some minutes, I would like to talk about 20 points. I don't think that I'm going to have time to touch on all those 20 points, but we can leave that for later. Ben actually talked about the major concerns that we have when it comes to assessments. And Ruben complimented everything that Ben said. And I believe that we really should think about all of those concerns. I believe that Ben asked if we need equating, and I think so. I think we do, for accountability purposes and also to assess the gains that we have over time. And we can only do that through vertical equating. And of course, there are many factors that should be controlled for. And in order for us to do that, we need the help of a group of people taking care of SAEB. But there are many concerns, as I said before. And even though we are careful, sometimes we see a compression effect or shrinking effect on the scale, or an expansion effect. So sometimes you have distributions that function in an appropriate way. And in order for us to avoid that, we need to be careful about some technical issues. And some of those concerns are not actually technical. They are related to how tests are administered. Two different administrations can produce two different results. So that point has to be very clear. Another very important point that always comes up when we are talking about SAB results is this. Can we see gains that are the same numerically for 5th grade, 9th grade, and 12th grade? No, we shouldn't expect that. We shouldn't expect to see the same growth in different grades because they are in different points of the scale. So ask someone that's 50 years old to grow like a 10-year-old is growing. We can't expect that. And that's very easy to understand when we talk about ages, right? So the proficiency across grades works in an S shape. And at the end of the scale, it is increasingly hard for us to see a large growth. So if we are to compare the grades linearly, we would need a logit scale, and we should understand that we are not going to see major impacts at the end of the scale. And Ben and Ruben said that items have to be comparable across different grades. We can't have DIF. And DIF sometimes is small and it can grow. And across grades, there might be larger differences. In one same grade, the effect is not that large, but the impact may be larger or greater when you look at different grades. Now, item quality. It is essential that we have high quality items, especially common or anchor items, because they are going to be the very foundation of equating. So it is very important that we have carefully chosen common items. They can't have drift. They can't present a drift or diff. And we have to control and assess those items every year because those items may not be appropriate next year or in 2 years' time. And of course, equating needs items that are not too hard or too easy. And if you calibrate the items that are not appropriate to that population, then you might see some differences in the values, and that will cause impacts on equating. So items that are not appropriate to that population, they should be avoided. That shrinkage effect or expansion effect were worrying in the beginning, but they were minimized over the years. Some programs worked in order for us to control that. They worked very well, including when it comes to weighting. All of those programs decreased those impacts. And when we are using a scale for many levels, we still have problems. We still have problems in terms of time because it takes a long time to grade the tests. And we also have problems when it comes to accuracy. And everything that Ruben said in terms of dimensions, I believe that we have already covered and solved all of those issues for SAAB. And they should be really a concern for us because there are many studies that show how much they can impact the results of vertical scaling. And especially when we have high stakes tests. SAAB has been administered for many years now. And in the past years, it grew in importance. What do I mean by that? I mean that even before, when we had items that were well controlled, now that the test is a high stakes test, the situation can change completely. And there are many other factors that we should be careful about, but they are not that concerning to us. For example, is our proficiency distribution in SAEB effectively normal? And what if it weren't? Would that have a major impact? We do have some studies that show that if we have some departures, the results are very stable still. So we shouldn't see much impact on estimated proficiencies or the averages or means. And of course, if our distribution is too asymmetrical, then the impact of that may be larger. And for SAAB specifically, in the past years, now that SAAB is a high stakes exam, now we have to look into different characteristics of the test. For example, in terms of asymmetry and in terms of having a distribution that is the result of mixing different distributions. That may also cause impacts.
The number of steps and the convergence process, that is already better controlled by blog. And in MES, they need more steps to reach that convergence. But in blog, it's better controlled. And that is the standard program that is used for ENEM and SAEB. And I think that's it. The choice of population for reference is not a problem. Of course, if there are populations with deviations that are too large, then you can see you're one standard deviation away from me, but another one is two standard deviations away from the other. But in equating, we can control that without larger challenges. And I'm coming to the end of my time, but there are a number of points that we can discuss, and we have been making good progress, but there will always be other points that we will need to work on several levels. And Alina said this is not trivial and calls for a lot of research for us to have a process that is well controlled. That's all I had to say. I only covered 6 or 7 points, but there's no more time. So thank you very much. Thank you, Wellington. Wellington, thank you. Thank you, Ruben. And Heliton, he does many things, right? But one of the things he does is that he's in charge of the São Paulo system analysis, and the São Paulo state has a very large number of students, and he does that. All right. So that we have 2 questions. I'm going to ask the first one. I'm going to be asking the question in Portuguese, and you'll be listening to the translation, Ben. So this question came from Reinaldo Fernandez. He was a director here at ENEM. And he said that in some systems where we have vertical scaling, we can see that the score gains per grade studied will reduce the higher the level is, and the standard deviation has been reduced. To what extent could this be a consequence of the way the scale is put together? And I have a question that is related to that myself. So whenever we think about calibration, we have an initial stage where you're calibrating the items. There could be an integration that is outside that, but you'll assume there's a point and there's a distribution. And when you estimate the ability of the student, you also estimate or assume a distribution. So these characteristics of the method, could they explain when you're doing it through many years using the same distributions, how much could that explain this decrease? that the scales go towards the center, because it looks like they're going towards the center, which is where you have the 0 of that scale fixated. I'm not sure if that was a clear question, but I hope you understood it. So Ben, I turn it over to you for you to answer and for the others to comment as well. Thank you.
I have a few thoughts on this. I also wanted to note there was another question that I partially resolved in the Q&A. So I think this is a fascinating question. There's an old branch of literature in the US asking basically about whether we should expect variation in our measures of student ability to grow or shrink as we watch students age. And I just think, conceptually, I find this to be a fascinating problem that we don't really have great insight on. Like when I think about, say, ability in mathematics as we go from, young kids to older kids, I think oftentimes we see in terms of the test scores, we see shrinking variation in abilities across those grades. But conceptually, I think it probably is the opposite. There's variation in third graders and how well they can do mathematics, but I think there's much bigger variation in 12th graders. And my hunch would be that this is likely due to the fact that multiple choice items and the other kinds of probes that we use in educational measures become increasingly insufficient to capture the kind of variation that exists in those higher grades. And that's just a conjecture. I could be wrong about that, but I think that's a great question that has been observed in other places, and that from my perspective, we don't have a good answer to. I don't know that I totally followed the kind of second part of that about the scaling issue. Maybe one of the other panelists would be better suited to speak to that.
Ok. Obrigado, então. Alguém quer, Ruben ou...
Thank you. So Ruben Halliton, would you like to comment on the questions? The second question was about the distance from the reference, right? So the deviation from the reference, was that it? Yes. So when you look at the first grade, it was 97 when we established that the average proficiency for Portuguese and mathematics was 250. And the fourth grade, which is now the fifth grade, was 190.8, and the third grade was 288.7. But when you look at 250, that 250 decreased after that, and is now 265.2. Now this 15 points difference, it's very small, and the impact is small to actually be a hurdle in the estimation process. Otherwise, it would have been a hurdle in the first grade. The impact would have been the same. The third grade, it had 297, now it's 298.5, so it's very close. 278.5, rather. So 199.8, now it became 227, so it dropped, then it increased. And these are mathematics incompatible values with the values for Portuguese as well. So I do understand your concern, but I think that the impact is not major for it to produce results in a way that they're not reliable. So in short, I think the impact is small. This deviation is small from the fifth grade to the 12th grade. The other questions, I think one of them, Ben has sort of answered already. Oh, can I say something? So the fifth grade, so the fifth grade, the first group was where we started focusing on improving education, because in Brazil, we didn't speak about education quality until SAEB. Education in Brazil until 1995 was basically building schools. And in 1995, we started SAEB, and when SAEB scales started being interpreted, then education quality started being discussed. And PISA also stressed that point and the concern over education. That was a point that was never discussed, and currently we look at SAEB results and PISA results, and the media splashes it on every newspaper. So we have a lot more people that get to the end of the 5th grade and get to the end of the high school than we did in 1995. So the change started then. So then we had a decrease in average performance, and then that started being recovered. So currently, we have better results, and with a lot more people being assessed in the final grades. So the population has, as a whole, improved. We have more people getting there and with a better grade, despite the fact that the average grade didn't get better. In the 5th grade, there was a clear improvement, and the 9th year is getting better now as well, the 9th grade rather. And there's a lot of concern about high school at this point. And high school and public schools, it started in 1997. I mean, the concern started in 1997. This accountability started in 1997. So we have EDEB that was created by Reynaldo, and the approval rates, they improved, the flow improved, and performance also started to get better. So the first improvement was in the 5th grade, and now the 9th grade starts to improve, and the 12th grade as well, so the 3rd year in high school. SAEB was being administered at the end of November, start of December for some time, and students had already done ENEM, and the best students were probably not attending the test. And then we started doing that before ENEM, and the results improved in comparison to private schools, and they had dropped before that. So there are many causes that could affect the performance. The date when the test is administered and the student motivation and so on and so forth. I'll ask 2 questions now for us to continue with our discussion, and then you can pick the question you prefer to answer. So the first question is, the position of the item in different tests could have an impact on performance. And another question is, how far can we compare qualitative interpretation of the 5th grade score with the 9th grade score? For example, say that a 5th grader has a higher score than the 9th grader. How far can we actually believe that the 9th grader is able to respond the items to the 9th year than the 5th grader the 5th year? Let me try and say something about this.
Well, when it comes to the first question, yes, absolutely. The position of the item in the test has an influence on performance, but you can use calibration to try and control for that. You can calibrate the item, placing that item in the middle of the test. So ideally, you can have the items in the same position, but it's very hard to do that. And that's why we usually see items in different positions in the test. The problems when it comes to DIF are not very large when we change the position of the items. So I believe that balancing the items, including in ENEM, we also do that for ENEM, it helps minimize that position effect. It is one way to minimize the position effect. If it's zero, if there's no effect, we don't know that, but certainly the effect is minimized. And about the second question, of course, we look at the interpretation of the scale. When you interpret a scale at the 5th grade level, we expect students to have to be able to answer the 5th grade items when they get to 9th grade. And of course, that item has to be covered from 5th to 9th grade. So we have to understand exactly what 5th graders are able to do, and at 9th grade, the students theoretically are able to do whatever 5th graders can and more. The proficiency estimation is calculated according to EAP, expected a posteriori. So when students ace the test, when they get everything right, it doesn't really mean that they have a higher ability than the other students, than students in 5th grade, for example. If everybody gets that item right, maybe the estimated proficiency may be inflated. If the entire class gets it right, then your estimation for that school is inflated. It is higher than the appropriate estimation, and you can correct that with adaptation tests in order for you to be able to adapt the test to each student's ability. But it is practically impossible to do that with one general test. I don't know, Ben, would you like to say something about that? But I'll go first, and then you can answer as well. Well, when it comes to the position of the item, I think that's very interesting, especially when it comes to ENEM. Some items tend to decrease in the likelihood of students getting it right if they are placed towards the end of the test. But for some items, it's the other way around. Sometimes the items that came before that particular item gave students the answer to that item. So in some cases, you can see that impact, but in general, if some items will not have a higher likelihood of students getting right if they are towards the end of the test. With some items, it's the opposite. And again, there is some effect, but when you look at the entire group of items, you can see that those items balance each other out. And for ENEM and SIAB, at ENEM, the item can be in 4 different positions. And that allows us to control that because the items will be in 4 different positions towards the end or more in the beginning of the test. And for calibration purposes, we control that effect. That effect is not something that really matters, that causes too much impact. So I don't worry don't worry about the position effect so much. If the item parameters depended on the item's position in the test, then we would never be able to have item banks. We could forget all about IRT. That theory wouldn't be able to be used anymore. So I don't worry about that so much. And that's all for me. And Ben, I don't know if you want to say something about that.
A few quick points. So with respect to the position issues, so I should have been more careful. So it sounds like NM has handled this quite thoughtfully. I was not trying to critique that test with respect to the issue of itemization. I was trying to emphasize that I thought it was a great opportunity for research, given that the items are balanced because of the booklets. Yeah, none of that was meant to be critical of NM. It was more about me being excited to show you that I'm trying to do some work with Brazilian data. The other thing I will say about the issue of comparing fifth and ninth grade students, literally based on this test scores, I would invoke the idea of construct underrepresentation here. There's always a concern between how well does the test as we've operationalized it match the abilities and the things we care about in real life. And one potential problem is that the gap might grow over the grades. I mean, this is a little bit what I was referring to when I was talking about multiple choice items being decreasingly effective at measuring the things we care about as kids get older. It also might be that the content just is not it's insufficiently broad in ninth grade, in the sense that it does not really capture all of the difference between a fifth grader and a ninth grader. Presumably there are many things that the ninth grader could know, even in that specific discipline, that aren't going to be captured by the test and that might be relevant for making really kind of detailed comparisons between fifth and ninth graders. So, that's not to say we shouldn't believe the scales in some ways. I just wanted to add a bit of nuance there in terms of what the scales might miss that might be relevant for that comparison.
Ok. Eu vou aproveitar também, vou fazer um comentário, não consigo me segurar aqui.
I'll make a comment as well. I believe that in the question related to fifth graders and ninth graders, I believe that there are 2 points that I wanted to mention here. The first one is the test is a sample. It is assessing part of the things that students can do. And the result allows us to make inferences for the entire universe of possible problems. But of course, it's a generalization, and it is subject to errors. And there are other problems that that group of students has not dealt with. And here we are talking about things that students did not learn from 5th to ninth grade. And since students have a higher grade than ninth graders, then fifth graders should know more than ninth graders do. But that is all underpinned by one dimension. And if the likelihood to get the item right is based on one single dimension, then you can interpret that result like that. So if the item sample is representative of the entire population and it is a dimension that's very important, then you could theoretically interpret it like that. But I think that it is just a sample. It is a type of problem, for example, multiple choice. So it is just a sample. And the second point is, I thought that what you said, Ben, is very interesting. Sometimes it's easier for us to have one single dimension in one part of mathematics, but not for mathematics as a whole. So it is one dimension about that thing that the student is learning at that point in time. But sometimes you may learn something that's more complicated before than something that's easier. So there may be fields of mathematics in which you can learn things in a non-linear way. So this aspect related to having one single dimension, it's tricky. I think it's hard to assume that. And let's think about that example, 5th and ninth grade. There are many different grades between one and the other. And I've seen examples for mathematics, for example, division. A fifth grader remembers because it's fresh, they just learned that. But in ninth grade, they won't remember the details anymore. So you are going to see some DIF. And when we analyze it, you can see those effects. You can see that there is a differential behavior for that item. And I remember one example when it happened, and I wanted to understand why. But that happens. Sometimes the students don't remember anymore, and sometimes, and now, if we have computers and calculators, they simply don't remember some details about division. We do because we're older, but students don't do math calculations on their own anymore. And if you learn that in fifth grade, you won't remember anything anymore when you get to ninth grade. So sometimes that's why fifth graders get questions right that ninth graders can't. Yes, and there's a second dimension, which is exposition or practice, or being able to retrieve that information that you have in your memory. And that ability is higher for students who are just learning that, and it is lower in students that have learned that in a long time ago. And I think that's a very important point about what Ben said, being the focal point in the curriculum. It is important to think about how the curriculum focuses on that item or that aspect. I think that may have an impact as well, because it is going to affect the second dimension, which is the exposure to that type of item. I think that's very important. We should look into that as well. We have another question here. We have not answered it yet. It was asked by Denise Rocha. Um, I, Let me see, where is that question? I think that we have already answered it, maybe. Alexandre Russi asked, is there a consensus about the characteristics that can impact the division or the selection of the populations besides the teaching modality and grades? And there is a question by Dalton as well. Dalton is asking, he's actually saying that an item like that shouldn't be an anchor item. Dalton, since we were talking about many different things and you said that type of item, we don't know exactly what type of item you are referring to. So if you want to go on and answer that question live, please feel free to do so.
Deve ser daquele item que
I think he's referring to the item, an item that was taught at a certain grade, but it was not reviewed in the next grades. Then that type of item shouldn't be an anchor item. Yes, I agree. It is an item that is not functioning equivalently across grades, then it shouldn't be an anchor item. I agree.
em suma são muitos os cuidados que tem que ter.
We have to be careful about many different aspects here.
Só uma pergunta aproveitando então, será que a gente consegue identificar assim, itens nucleares
And I have a question.
trabalhados ao longo da quinta ou sexta
Are there items that should be always anchor items? Is there a specific type of item that we should use as common items? Well, I think that the teaching team should assess that. When I was just starting, I tried to understand why that happened, but now I know the items. I don't really know why there's DIF or not, but I think that we should do that. We should understand why it is happening so that we can avoid that type of item as anchor item. So it is something that we should be careful about. Yes, I agree.
Yeah, the curricula have to be in line so that we can have clear assessments.
Can I make one note about that?
Yeah.
So I would just say, if you have 2 grades, the thing that I would want in terms of an anchor thing that is, kind of at the intersection of the content across the 2 grades. But what's going to happen is that if you have mini grades, the thing that is at the intersection of the content across each of the grades individually might start to be in very different directions. And so the thing that might make for a good vertical scale across 2 grades might then also start to lead to real issues with respect to vertical scales across mini grades.
Interessante.
That's very interesting. Let me just make a comment here. Saeb measures not only the 5th grade knowledge, but also what comes before that. And the 9th year as well, not only the 9th year, but what comes before that. So it's the end of the cycle kind of thing. So there's always items that are in common between the first cycle and the second cycle. There's a lot in common between the 5th and 6th grade and 6th and 7th grade. And but a 5th grader would never know what an 8th grader knows, but there are some common items that would allow that to happen. And we can see in high school is a problem for us. But students do best in high school when they're doing the elementary school items. When you do high school items, it's difficult for us to measure it. You can really measure it best with elementary school items. If we didn't have these common items, the elementary items would be very difficult to do anything with them, really. I have one last question that is here in the chat, and then we can draw it to an end because we're coming to the end of our session. How do you understand the differences that are observed between the means and averages calculated between the 5th and 9th grades and the averages that you find between the tests that you have in the states and cities? So comparing 5th and 9th grade means and averages in SAEB and the state's assessments.
Fazer comentário inicial.
Would anyone like to answer that?
Sempre que a resposta a item
I always say that the answer to an item doesn't depend only on the content of the item itself. It depends on the whole context.
quando o item é dicotômico, o sistema de
It can be a dichotomy in the item, and then the correction system needs to be automated. But if it weren't, then it would depend on the whole group of corrections that needs to be carried out, and that's a part of the item. It's part of the end result of that item. So in the same, by the same token, we see a group of other applications that have to be considered in the administration. So Portuguese and mathematics tests that are administered in the same day will lead to different results than when you have these same tests administered on different days. When we did that in Sabesp, then when we started going from different days to one day, the average, the general average dropped 10 points. So there are other examples as well. Saeb has 21 forms. The odd-numbered forms start with Portuguese, and the even-numbered start with mathematics. So if you look at the only odd-numbered forms average that start with Portuguese, and you compare that with the even-numbered that start with mathematics, then the averages are also different. It's about a 10-point difference. So it is very substantial. It really is. So the end result is also it also related to other points like logistics. So Saeb has a certain structure for it to be administered. At the end of each block, the students will stop a bit. So it has a certain structure. Now, state assessments are completely different. And they'll have to do the whole test do it through, and they have no breaks in between. And there are several other things that could have an impact on the results. So it's really a whole group of items, of criteria, really, that needs to be unified so that the differences between the national assessment, that is SAEB, and the state assessments could be minimized because they exist and they really are connected to these logistics points and how the test is administered, at least to my mind, I would say. Well, Maria Helena, I'd like to turn the floor over to you for some final remarks, if you may. Thank you, Ricardo. I will have to leave because I have another appointment, but I'd really like to thank Ben, Heliton, Ruben, and yourself, Ricardo. And this subject is absolutely crucial for education policies in Brazil. Brazil is going through a moment where there are major changes taking place in the curricula. There is a new national learning standards program. It's a common core, you could call it even, because each state in Brazil has its own curriculum. And from another side, ENEP, the institute in charge of these assessments, in 2021, it is going to start carrying out a number of changes in how SAEB is administered. The federal government will have an administration for all of these students in the 10th grade. The tests will be digital, and there will be open-ended items. We have only had multiple choice so far. So there is a group of aspects, and I'm no expert in metrics. I am with the quantitative side of it, but there's a number of aspects concerning public policies in education in Brazil that are under discussion at this point. And these changes will impact very much the education system. This point Elio talked about around how the state assessments are administered, even when they use the same scale, a comparable scale that is comparable to SAEB. That's a very relevant, very important comment. So these criteria that are unified, how can they compare, or how can the level of comparability be seen then? Brazil has a habit, so to speak, of assessing. We're obsessed with it. We assess too much. To my mind, I was the president of ENEP, this institute, for 8 years, from 1995 until 2002, and I was implementing SAEB with Ruben, and I was involved with PISA. All of these initiatives, I was involved with them when I was the president or chairwoman of ENEP. But I think that today there is a trend or a tendency to expand these assessments. So the points that Ben has raised and the aspects that Eliton, Ruben, and Prime understand in much greater depth than myself around verticalization and vertical equating and what points we need to take into account. These points sound extremely important to me, considering that we will get into a moment where there are a lot of changes taking place in SAEB and ENEM. Both of these tests are going to be changed. So I'd like to really thank you, Ben, for joining us and for your presentation. And we will certainly have other webinars like this one, looking at what's going on and what we can do in order to improve it. Though we do know that Brazil has a very high level assessment system from a technical perspective, we can just look at the panel that we have here, right, with Ruben and Ellington, but also other people that are not with us here today, with Katia and Soares, and I have to say that Brazil has a group of experts in assessment that are really qualified, and we continue to work to improve on what is being done. And we're a bit concerned about the effects coming from the pandemic on the assessment. So thank you very, very much. Thank you, Maria Elena. So we have then come to the end of this webinar. I'd like to thank you very much. Ben, would you like to say something, please?
No, I just thank you again for inviting me. This was a real treat, and I hope this is the first conversation of many.
Tá bom, então a gente que agradece, com certeza será.
Thank you very much, Ben. Certainly going to be the first of many. This is an important partnership, so thank you for that. And thank you, Ruben. Thank you, Ellington, as well, for joining us. Thank you for our supporting staff, Leandro, Silvia, Priscilla, Thais, and Marilia and Renato, the interpreters. Thank you for assisting us in translating this challenging topic. And I'd like to thank you all for asking your questions as well and watching our webinar. So this is it. Thank you very much. Bye-bye. Thank you, Ben. Thank you, everyone.